Hey, what's up everyone? My name is Arvid, and in this video I want to show you how to create a realistic rendering scene using the new Maya 2017 and the built-in Arnold render engine. So before we jump into Maya, let's have a quick look on the reference image. So this is what you will be creating. A simple glass shader with a liquid and some varying wood sticks. This is the rendered result I was getting. It's not the same environment, so it looks a bit different, but the similar surface attributes persist. So you can actually see the refraction is behaving as it is in here, and also the liquid surface tension is also behaving as in the reference image. So let's jump into Maya. This is what the rendered scene looks like. It's really basic. So I've got the white wall, I've got some wooden closets, then I've got one key light, and I've got an HDR light which produces the nice lighting temperature. So the model consists of the outer glass, and then we've got the liquid inside and the sticks which go through it, and also the plastic which is hollow in the top so the sticks can pass right through it. So let's undo these. So before we start assigning shaders, let's see what the general lighting looks like. So it's nothing special, it's really just one direct light, and then we've got the HDR which gives you the color mood. So that's actually all there is to it, and this lighting produced this image here. So let's just jump right into it, and let's start with the glass shader from the outside. So right click this, assign new favorite shader or assign new material, and go to Arnold, and then you add the aiStandard shader, which is the basic default MtoA shader. I always like to work in an active IPR session. So let's start IPR again, and let's look through the render camera. So this is the render camera, and I'm with shift control dragging, you can drag a region, and you see the bucket sizes are quite big for this small resolution. So let's change this quickly. Going to the render globals and moving over to system and changing the bucket size to be really small, so we can see quicker results. For glass, it is important that you disable the opaque, otherwise you won't get transparent shadows and you will get black shadows for refraction. So let's be neat and rename this AI glass. Okay, got this already in the scene. AI glass shader. And glass doesn't really have diffuse contribution, so you can actually just remove the diffuse color and also the weight. So specular weight, glass mostly doesn't have any roughness, but it is specular, and enable Fresnel, so you get actually nice Fresnel reflection. So if this is on, you get the proper fall off on the edges. Not sure why it's wanting to create a node. So if you also want a bit on the front some reflection, then you can add a reflectance at normal, which essentially is the IOR. So the higher this is, the more reflective the object gets. So for glass, well, you can add a tiny bit for the front. Typically glass is see-through when it's full on 90 degrees, but it just gives a nicer look, and you can actually see the HDR being reflected in here. GGX is the fall off for the roughness, which is a new mode in the MtoA core version. Beckman was the default one. They added GGX, which gives nicer tails of the roughness reflections. So let's go to transmission or refraction, and all you gotta do is enable it using the weight, and then on default there is no IOR, which is index of refraction. For glass it's something around 1.45 or something. Liquid is 1.3. It's all, you can all find everything on Google. So what you could do is just glass IOR. Yeah, not this stuff. So I don't know. V-Ray info is quite good, I guess. And then you get all the IORs you want to find. So glass is 1.5 actually, so I'm a bit off. And let's check what water is. Is it called water? Yeah, water at 35. It's 1.33, so that was correct. So let's change this then to 5 for the glass. And this is the basic setup. In real life, nothing is perfect, so all the reflections currently are really CG-like. So what I always like to do, let's just frame this guy. Where's the reflection? So what I always like to do is I add a really soft bump map on top of this, so you get a soft bending of the glass. You can actually see this happening here in the reference image. You can see that this is not a straight reflection essentially here, and when you zoom in quite close, you can even see that there is a micro bump on top of the glass. So let's try to mimic this. Here you can see it quite good. So what you got to do is create two noise patterns, one for the soft noises and one really tiny one for the detailed noise. So I like to do this in the new Hypershade, which is also quite nice, which has a real render engine, and this is actually connected to MtoA, so you get the proper result in real time. So not sure why it's not updating the shader. Because it's not selected. Interesting. So let's select this back, AI glass, and do this. There we go. So here's a glass shader. I tend to disable this view because it's not as fast as the Arnold render viewer. So I like to disable this, and it doesn't have all the nice features actually. So let's create a AI noise, and let's create another one. Let's just call this broad. Is that a term? Broad noise. And duplicate, Control D, and call this micro noise. So let's combine both noises using an AL combine float, which is, if you work with Nuke, it's similar to a mix node. So you can just put the output of the noise 1 and noise 2, put them together. They are connected here on the right side. And if you choose your mode to lerp, which is the same as Nuke's mix, so if this is on 0, it is input 1, and when you put this on 1, it is input 2, which is a bit weird, but it is how it is. So let's connect this to the to a bump map. So I'm just scrolling down here and finding the bump mapping and middle mouse dragging this into the bump slot, which creates a bump 2D node. So for now, I just disable the bump and make this UI a bit smaller, and let's start the render. First let's save a session. Doesn't like to save. File, save, scene as. This UI is in front. There we go. So let's call this training. And let's start the renderer, Arnold render view. And it has really nice features. For instance, it has this isolate selected. So whatever you select, this is what will be rendered. So if I select this now, you can actually see the direct output of this node. So let's tweak this. We want this to be the broad one. So this is actually quite good already. It's got the broad bumpiness to it. Let's just add an octave more, so we get a bit more detail. So this is a nice one already. So let's jump ahead into the micro noise, and this one also more detail. But let's increase the scale to 5. Possibly we need way more. Yeah, so if this is a close-up like in the reference, and we want to create this kind of pattern, we need to go way more. Let's say 25. Even more, I think. Let's try 50. So let's compare this. Yeah, the size is maybe a bit small now, but let's stretch this as well in one direction. So if I go back to 30, that's the wrong one. It's always it's always the other one. This one as well. Okay, so this is now my micro noise, let's call it that. And if I combine them, you can see that this is now on 1, which is output 2. If I put this to 0, it jumps to the other one. So now, if I mix the small one together, you can see that we get a really small micro noise on top of that. And this is driven in the bump map. So if I go back to shading, and I just go here, for now let's just disable refraction so we actually see the results. So no refraction. And let's add a bump, small one. It's really sensitive, those values. So you can already see this is way too strong. So let's dial it back down. This is now changing the mix. So still, also you see that the bigger one is also too strong. So let's first dial down the general bump amount to 0.1, 0.1. So, okay, it can be a bit stronger. So this is actually trial and error all the time until you're satisfied with your result. So I think this is quite nice. The micro noise is still too strong. So let's reduce this a bit more. So what do we got now? Yeah, it might work already. You see how sensitive these values are? Yeah, okay. I think 0.1, 0.01 is a good trade-off. So let's enable back the transmission. It's not that apparent, but when we introduce the liquid, we will see the result. So let's create the liquid shader. I like to do it step by step. So what I want to do now is just hide the glass and assign a new shader onto the liquid. aiStandard. Let's call this AI liquid shader. It has the similar attributes as the glass. So let's remove the fuse color. Let's add specular weight, no roughness, weight is on 1, GGX, and Fresnel is on. Let's give it a small value for the facing angle. Let's say 0.02, and enable refraction and the IOR of 1.33. Fresnel use IOR. We actually need to turn this one on the glass as well. So let's select the glass shader and enable Fresnel IOR, which essentially is also using a Fresnel calculation on top of the Fresnel for the refraction. So selecting the liquid and creating a new tab and adding the shader. So this is the liquid shader. For this, it's mostly smooth surface, so we don't need the bump map, but we want to have a liquid color like in the reference, which is a pink rosé liquid thing. So starting the IPR session again, I'm actually pressing spacebar to bring up the HUD menu. So as you can see, the liquid is now really just transparent. Also, the opaque switch is turned off for the liquid, otherwise we wouldn't get transparent shadows. So to change the liquid color, most people would think, let's change the refraction color like this. It does work, but essentially it's not physically accurate because it's just tinting the whole thing the same way. What you need to do is you need to go to transmittance, which is essentially the color based on the surface thickness. So when the liquid is really thin, like shallow water for instance, it looks like it's clear water, but the deeper the water gets, the more particles are in the water and the darker the color gets. So this is what transmittance actually is doing. So we should see the top should be more transparent, and the deeper it gets, the darker, the richer the color. So you can see that's on the top here, it's mostly transparent, like white. So this is the difference. So if I would change this back to be white, and I would just change the color, this would be overall pink, which is wrong. So let's put this back to white, transmittance back to the pink color, And let's tweak it a bit. So I think this is too saturated. If you double click on the color swatches, you should get the dialogues. Maybe it's hidden behind these guys. Yeah, there you go. And it's a pop over dialog, so it does not is not being closed when you click away. So let's change the saturation to make it not so bright and vibrant. If you want, you can also copy the colors over. So, but it's just a general idea how to shade stuff. So this is my liquid now, and let's hide it. Oh, I didn't save. That's bad. So let's just do this again. Desaturating, and okay. So this is it for the liquid, and let's start with the plastic on the top here. This will now, you can also create nodes in here if you press tab and aiStandard, and as you can see in the reference, there's a bit of noise on top, so it will also, I will also add a really soft bump map on this. So let's first call this AI lid shader, and this is now a plastic material, so it won't be with a black diffuse. So let's assign it first. Assign to selection, and let's start IPR. If you go to window toolbar icons, you can enable show 3D manipulation icon, which is this guy, and this is a toggle for either panning the frame buffer or panning the CG camera. So it's also quite helpful. So let's first adjust the shader to be a white plastic. So most of the plastics have diffuse contribution, possibly not perfect white, but it's not because the weight is on 70%, so it's a bit more than mid-gray. And then there's a roughness. So first enable spec and enable Fresnel, which is important, so you get a Fresnel fall off. And you can add a tiny bit of front-facing reflection, and let's dial back in the roughness. So let's put this maybe a bit higher, so it's almost perfect white, and then you should get some really soft reflections here, which you can see quite nicely from the area light I have behind the camera. And for this, it's maybe a bit too shiny now, but let's first add the bump map. So another AI noise, tab AI noise, and this goes directly into the bump slot. So middle mouse drag and into the bump. So if you want to have control, you can switch this back to isolate, then you see exactly what the noise looks like. Sometimes it's not updating, so you would go to update full scene, and then it works. So definitely way too big. So let's try 50. Is that already okay? Yeah, this might actually work already. So 50 might be fine. Definitely too strong. So 0.05 maybe. Okay, it's getting there. Might be still a bit too strong. And maybe generally too shiny. So let's increase the roughness. Yeah, I think this works quite well now. Yeah, it's really subtle, and you can see that there is something happening, but it's not too strong. So let's jump in to make the metal. So another aiStandard. Rename this, double click on the name, you can rename it inside of the node editor, and call this AI metal shader. And if you click in here, you can actually select your object. So let's select this guy and assign to selection. It assigned it, and metal is quite straightforward. So it has mostly no diffuse as well. It has a Fresnel, and it has a lot of reflectance at normal. So this should go high, and you should increase your weight, otherwise you will never see anything. Like this, and then reduce the roughness, and this is a really shiny metal now. In the real world, it's not that shiny, so you would reduce the weight a bit, increase more roughness, and something like this. Maybe it's still too strong, so you can dial this back down a bit more. You can also, if you want to tint it slightly in a gray bluish way. Is that working? Spec color, yeah, it might work. So this is a really basic metal shader. It's something you see in most appliances, so it's like a chrome based thing. And always keep in mind, never have perfectly mirror stuff. There's always surface roughness to it. Maybe not too strong, but something around this should work just fine. So this is it for the metal part. So let's jump in and make the wood shader with a displacement map and a color variation using user data float. So let's hide the lid. So all we have is left is with the sticks. So how it works is you assign a shader, like all the same we did before, for the variation, but you need to add attributes to each one of those, so you can drive the surface color using a float variation on top the shader. So how do you set this up? So there is no easy way of doing this. You need to do it by code, or you have to do it manually with all the assets you want to vary it on. So to do this, so to add the attributes onto the objects, first of all, they have to have, the attribute name has to have MtoA underscore in front of it, otherwise the user data won't work. So what this code is doing, it is for stick in PMC selected. PMC is primal core, so whatever I select and whenever I call PMC selected, it will return me objects in the scene. So for stick in the selection, which means it loops over the array, so it will print this guy and print this guy, and the more I select, the more loops it will go over, iterate over. So let's say I want to print stick, and let's run this. So it prints all my selected objects. So this is essentially what it's doing. And to add an attribute to an object, you need to select it. So what I am doing here, I select the current stick, and then I use add adder, which adds an attribute to this object. And the attribute ln long name is this. You can call it whatever you want. So this can also be, let's call this diffuse color, and dv is for default value. And what I'm doing here is I'm creating a random value, a random float value between a range 0.7 and 1. So if I import random, and this is the command, and if I execute this, you see I get always a different result, or I should actually. This was just a coincidence that they are so close to each other. So let's run this a few times. You can see that there is always a random value in here. Maybe if you want, you can make this a bit bigger. Let's say 5, and let's try this again. So the difference is now bigger. You get 0.6, 0.7, 0.9, all the way. So the loop goes over, adds this attribute, and sets the value here. So let's do this. You need to do this on the shape node. Yeah, so I tested this already, so it needs to go onto the shape. So what you can do is, if you don't see this plus on your transform, you go to display and enable shape. So you can open this up and you can see the shape. If you don't want to do this, just select them and press the down keyboard key, and it will select the children of this. So now all the shapes are selected, or you can see this here. So all they are now selected. So let's print again stick. So now you should see that all the shapes are being printed. So, and all I have to do now is select this with my active selection and run it, and then you can see I'm adding this diffuse color, and on each shape it is a different value, and this value will essentially drive the shader diffuse weight contribution. So how's it called? MtoA diffuse color. So let's open the hypershade again and create a new shader called aiStandard, and this is the AI wood shader, and let's select all those guys. Is that correct now? Let's just do it properly. And right click assign to selection. So how does this work? We want to control this value here and not the color. So what we are doing here is driving the weight of the diffuse contribution. So you have to do is create an AI user data float, and the name is diffuse color without the MtoA underscore. You can set the default value. Let's just do this 0.8, and this guy, the out value, goes into the diffuse weight, into this guy. So middle mouse drag into the weight, which is the KD essentially. So if everything went as planned, we should actually now see a varying diffuse weight. So let's open up the render again and see if we get some varying color. So if you see this, it looks that this is brighter than the others, but it's hard to see. So let's select this guy and let's change the diffuse color to be 0, so no white. So it should be just black. So you need to retranslate the scene, and yeah, it looks like it did work. So yeah, it's actually working. Maybe the variation is a bit too not strong enough. So let's put this to 0.5, and this guy also smaller, and this guy maybe fully white, and let's retranslate. Yeah, so there's a dark one in the middle, and then there's a white one here, and mid-gray, and some slight variation, which is fine. So it's just to show you the practical way of doing variation with one shader. So now let's add a color, which is a brown wood similar color, a bit brighter, maybe something like this. Also, let's just add a slight subsurface scattering, really subtle, to brighten them up generally. So this is now kind of what we're getting here. You can see that they all have a wet look to it, and you can see some wood lines running down it. So we will try to achieve this using displacement. So let's first add some specularity with Fresnel turn on, and no, not so much roughness because it's a wet surface. And let's add a normal thing, and then you can see there is something happening on the surface. So for displacement to work properly, your object needs to be subdivided the proper amount. So currently this is highly subdivided already because I was doing some tests previously. So to subdivide your objects, all you need to do is go on in the shape under the Arnold tab, and under subdivision, enable from none to catalog, and then increase your subdivisions. But be careful, it goes really slow quite fast. So I was just testing this out, and putting this to 5 with the high frequency displacement map I'm using, it looks quite nice. So you can switch back to shading in the render viewer, and let's create another AI noise. Damn me and those noises. So this one, let's first see what we want to get. So I will plug this into my color value, and just for testing I will put this to be white so we can actually see the noise. So increasing the, oh well, that was stupid, excuse me. Let's just revert this. This goes KD, and this goes back to the color we just chose. Is it this one? This one? Yeah. And let's plug this into, just for now, let's plug this into the KSSS value, and then you can use isolate selected, and then you can tweak the noise. So let's try 50. First time luck every time. So what I want to do, I want to create these lines of wood or something. So I was just trying to stretch it, but I think 51 is already quite good. Yeah, so it looks actually quite good already. So this will drive the displacement now. So let's just unplug this and make sure that KSS, which is the subsurface scattering amount, this guy, the weight, has something. So let's put this back. So this is my shader. So to create displacement, you need to go to the shading engine and just drag the noise onto the displacement material, and it will create you a displacement shader. Currently there is no input, so the out value of your noise should go into displacement. So what is happening? So now you can see it's actually displacing my geometry, and it's doing it quite fast because it's an insanely amount of polys, and it's doing it almost in real time. So definitely too strong. So let's dial down the amount. Before we do that, there in the Arnold tab, you've got scalar 0 value, which means when you say it's 0, then it means that everything, every color value gets displaced in the positive way, so everything gets extruded. If you would put the 0 value to a float value of 0.5, it means that 0.5 is the 0 level, and any value below 0.5 will make the geometry smaller, but values bigger than 0.5 will actually extrude them, so you get a nicer overall look, I guess. Let's first disable auto bump. I'll talk about this in a second. So putting the 0 value to 2.5 already looks way better because it's not extruding so much, but still it's still too much, I would say. So let's just put it to 0.2 or something. So yeah, this is actually looking quite good already. So comparing this to my reference, you can see those nice lines. Maybe the noise is too fine, so let's just make this a bit bigger. So 50 is too much, let's do 30. Yeah, I think this works definitely. So let's see everything together. So let's unhide all the stuff I have been hidden before. So all these guys unhide. So we get the metal, we get the plastic, we got glass, we got the liquid, and we got those sticks inside of this. So let's start the IPR session. Let's look through the render camera and frame this guy. So this is now the rendered result. You can see that the color of the liquid is a bit too pink, so I would desaturate it, but essentially this is how you create a nice looking scene and with not so much effort, and it looks quite good. To make it look a bit nicer, let's add some depth of field, which I just disabled globally. So in the render globals, you've got on the override, you've got depth of field. I ignored this. So now I will be rendering the depth of field of a proper camera. You can see that it's blurry already here. To get a clean render, you need to increase your samples. So in the Arnold tab, increase those, I don't know, about 12 should be fine to get it crisp, but make sure the other ones are on 1, otherwise your render will go or take insanely long. Also, for the refraction, possibly if you tried this, you had a black render because you need to increase your refraction depth. I hope you did enjoy this short video on how to create some basic, nice looking shaders inside of Maya and using MtoA. Thank you guys for watching, and check out my other tutorials on my page.